Okay, guys, let's review the power to a power rule for exponents, our last rule, and scientific notation. So to simplify power to a power, remember every factor inside your parentheses, a factor is something that's being multiplied, has an exponent. And so we're going to take this outside exponent and distribute it and multiply it to each exponent inside the parentheses. So we get a to the negative 10 and b to the 25. Now notice this negative 10 is on the a, and we cannot have a negative exponent. So we are going to get b to the 25th over a to the positive 10. Okay, in this expression, we have 1, 2, 3, 4 factors, and we're going to distribute and multiply the 3 times every exponent. So we're going to have 2 to the 3rd times p to the 21st over m to the negative 9th times n to the 12th. Now there's two things we can do. We need to evaluate 2 to the 3rd, and we need to reciprocate m to the negative 9 and put it in our numerator. So we have 8 m to the 9th, p to the 21st over n to the 12th. Okay, let's count how many factors we have here. We have 1, 2, 3, 4, 5, 6, 7. However, notice within, before I start distributing, notice I have several y factors and several z factors. So I'm going to go ahead and use the product rule and the quotient rule. So if we begin, we have 3, and then we can combine y to the second times y to the first, that's y to the 3rd, z to the negative 1, and then in our denominator, we can combine the z's. I still have y to the negative 1 right now, and z to the 4th times z to the 1st. We're going to use the product rule again. And now we can simplify even further before we multiply by our exponent of 2. We have y to the 3rd over y to the 1st, negative 1st. And so this is, we're going to be using the quotient rule. So I'm just going to have 3, and then I have a y, and it's 3 minus negative 1, and that gives us 4. So our exponent is 4, and then we have a z factor, and it's negative 1 minus 5, and that gives us negative 6, all raised to the second power. Now I am down to 3 factors, and I'm going to distribute this 2 to each of these exponents. So I have 3 to the second, because 1 times 2 is 2. I have y to the 8th, and I have z to the negative 12. So we're going to evaluate 3 squared, and we're going to reciprocate z to the negative 12. So I'm going to get 9 times y to the 8th over z to the positive 12. Now we're going to make adjustments. We're moving into scientific notation. And I have 3 examples of what seems to be scientific notation, but they're not proper. So we're going to make adjustments. So we need a number that's 1 or more, and this is not more than that. So I'm going to say 3.4. So I went up in value here. I multiplied by a 10. So I took a 10 here, and so that's why I have 10 to the 5th. So if you make 1 decimal move on the left, then you have to make 1 exponent adjustment on the right. Okay, this time we have a number that's more than 10. Remember, it has to be from 1 up through to 10. And so we're going to make this 7.21. So I went down in value here. And so now I need to add in that extra 10 that we used to divide to get this decimal. And I'm going to say 10 to the 3rd. So these two are equivalent, but this is improper scientific notation. Okay, here we have 0.02. So I'm going to go up in value here. So I moved it 1 and 2. So I moved it twice. And so I have 2 because I moved the decimal twice. So I have to make an adjustment on the exponent of 2. So since I went up in value here, I'm going down here. So I need to go down 2 exponents from negative 8, and that's negative 10. Okay, now let's convert to scientific notation. This says convert to scientific notation. That really should say convert to standard form. It is in scientific notation. Okay, so standard form. So this this exponent tells me that it's going to be a very small number because of the negative. And then the 6 tells me that I'm going to be moving the decimal 6 places, and I'm going to go left because it's going to be a small number. So I have 401, and I'm going to move the decimal 1, 2, 3, 4, 5, 6. And then I always like to put a 0 as a placeholder there. Okay, again, this should say standard form. And again, my exponent, because it's positive, tells me I'm going to be moving my decimal to the right, making a very large number. And the 3 tells me how many times to move that decimal. So I'm going to move it once, 2, and 3. Okay, again, we're going to write to scientific notation. I had all of these backward, but that's okay. We can fix it right here. So because I have a very small number and I'm going to be moving my decimal to the right to get to right here, I know I'm going to have a negative exponent. So sometimes I like to go ahead and mark that down before I forget. So it's going to be 9.02 is my coefficient. And I'm going to move it 1, 2, 3, 4, 5, and 6. So negative 6. Okay, and guess what? I'm sure I have the wrong wording here. I do. So we'll fix that. So I'm just going to put SN for scientific notation. We notice we have a very large number, so our exponent is going to be positive because we're moving our decimal to the left. So it's going to be, again, times to the power 10 to some exponent. Whoops, let's not write that. That's supposed to be an underline, but now it's going to look like a negative. Let's back that up. Okay, so our stopping point is going to be here for our decimal because, again, you want one digit to the left. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have an exponent of 9, and our coefficient is 8.21. Okay, now let's get into add and subtract. And remember, when you're adding, it's kind of like adding like terms. If I say 8A plus 2A, I get 10A. The A is the A. But if I had like 8B plus 2A, I can't combine these. It's the same deal. So our power of 10 kind of acts like our variable. So these have to be exactly the same before I can add the coefficients. So we're going to make an adjustment, and we're going to turn this in to have an exponent where we have a 3. And so I'm going to say 10 to the third. So I went up here. So that means I need to go down in value here and make it 0.6. So I have 0.6. These are equivalent. And now I have powers of 10 to the third. So I have 4.01 times 10 to the third. And now I can add coefficients. So it's 4.01 plus, lining up decimals, 0.6. And my new coefficient is 4.61 times, and I just carry over 10 to the third. And it is written in proper notation. I do not have to make any more adjustments. Okay, let's do the same thing for subtraction. These powers have to have the exact same exponent. So I'm always going to take the smaller one and make it into the larger one. So negative 6 is smaller. So here I'm going to go up by 2. So here I have to go down by 2. So I'm going to move the decimal 1 and 2. So I move the decimal 1 and 2 because I went up 2 exponents here. We are subtracting. So we're going to have 8 minus 0.09. Okay, so that's going to be 7.91. 7.91 times 10 to the negative 4. And again, my digit, I have one digit to the left, and my number is 1 through up to 10 and not over 10. Now multiplying is a little bit easier in that all you do is multiply coefficient times coefficient, so we get 72. And then we're going to multiply like powers. So we're going to use the product rule and add our exponents, and I get -10. Now, 72 is more than 9, so we have to adjust this. So it needs to be 7.2, and so we went down here, so we're going to go up on the right side to keep it balanced, and that's going to be a -9. Be careful with your negatives. Okay, and dividing, we're going to divide our coefficients. So 2 divides into 8. That means the top goes in the box. So the top number goes inside this box, and I get 4. So I have 4 times 10. We're going to use the quotient rule. We're dividing like powers, so you subtract exponents. 4 minus -2, and that gives me a +6. And guys, I hope this video helps you for your quiz.